Hello, this video is trying to find the limiting reactant and what that's all about. So taking a look at this problem, it says that in the equation we have a complete combustion of ethane, which is C2H4. It says that I'm going to add 2.7 moles of this and react it with 6.3 moles of this. And if I do that, I want to know, well, how much of my stuff will I actually make? Now the question really is which one will I run out of first? So limiting reactant, not both of them will be needed. Like when you make a peanut butter and jelly sandwich, you've got a whole jar of jelly and a whole jar of peanut butter, but you only have so many pieces of bread. So you need to figure out like what's your limiting reactant in peanut butter and jelly sandwiches. Usually it's the bread because you've got the whole jar of the other stuff. So we have to figure out like which one is my bread in this example and which one is my peanut butter or jelly. So I really have to ask myself like how many moles of one of my products, maybe water, will I make when I've got 2.7 moles of C2H4? That's my first part. And then I have to ask myself, well, how many moles of H2O can I make, or product, when I've got 6.3 moles of oxygen? Just like with the peanut butter and jelly sandwiches, like how many sandwiches can I make out of the materials I have? If I have a loaf of bread and a big jar of peanut butter and a big jar of jelly, I know that my peanut butter is going to be tons of it, jelly will be tons of it, but I'm going to run out of my bread eventually, and how much bread I have determines how much product I have. So I'm trying to ask myself, well, how much product will I make, H2O, from this much bread, jelly, or peanut butter, and this much bread, jelly, or peanut butter? Okay, so here's my problem. If I've got moles of C2H4 on top, I'll have to put moles of C2H4 on the bottom. That way they'll cancel. And I need to get into moles of H2O, so I'll put that on top. Same thing happens on the bottom here. I've got moles of oxygen on top, so I'll put moles of oxygen on the bottom. That way they'll cancel. And I want to get to moles of H2O on top. So now I've got to put my numbers in. Here's where I use the balance equation. I've got 2 waters that I'll make. 2 waters. My oxygen I'll need 3. And my C2H4 has a 1 in front of it. So now if I do the calculating, I will get 5.4 for this top number. And 4.2 for this bottom number. So I gotta ask myself, well, how much water, H2O, will I actually make? Will I make the 5.4 moles or 4.2 moles? And the answer would be that I'm actually going to make the 4.2 moles. Because after 4.2 moles, I'm going to run out of oxygen. Oxygen is my limiting reactant. Which means I've got tons of my C2H4, and that's called my excess reactant. So now I've just identified my limiting reactant and my excess reactant, and I also know how much water I'm going to make, 4.2 moles. Another part of this question that you'll have to know is how much excess reactant will you have left over? Like when you're making peanut butter and jelly sandwiches, how much jelly do you really have left over? In this case, my jelly is the C2H4. So I'd ask myself, well, how many grams of C2H4 will I have left over after I make 4.2 moles of water, H2O? Alright, now I've got a strike problem. I'll have to put moles of H2O on the bottom. That way they'll cancel. And I'll have to put moles of C2H4 on top. Here I gotta use the balance equation again. 1's on top, moles of water is 2. I gotta get out of moles of C2H4, so I'll put that on the bottom. That way they'll cancel. And into grams of C2H4 on the top. This is using my periodic table where 1 mole equals, I'm going to take 2 carbons, 12.0 on 1, and 4 hydrogens, which is worth 1.079, and that's how I got my total of 28.0536. So now that I do my calculations, I can divide by 2 and times it by 4.2. I get a whopping 58.9, or sig figs to be more proper, 59 grams of C2H4 that would be left over. That's how much excess reactant